So, and this is these are other applications like finance planning. Try to see what is the best way to run the business. Should we put the cash in investment, or we should invest more ourselves or buy company or whatever? They have all the formula. I mean, they knew this before data mining, and data mining just helped them to make this plan easier. It doesn't mean that data mining just invent this for them. It's a big difference. Okay. Competition, like monitoring market, gathering, maybe just have a spider to gather all the data on the web and then analyze them, for example, to see what is the current status of the company. Next, there are so many potential applications, and actually some of them are at work. So auto insurance, for example, try to find if the claim is the true claim, or sometimes they just like the one who caused the accident knows the owner of the car, and they just stage the accident so that they can get the insurance, and then they may not have the real accident, but they file the form and whatever, and then if the insurance company can look at the pattern of why this driver hit so many cars, for example, or hit the same car so many times, and the same thing on the fraud detection in the medical, try to find malpractice or whatever, like it's okay. I cannot give an example now. Credit card, like the example that we previously talked. Telephone also, like this kind of thing is try to detect illegal use. If one customer always use like local call, the same pattern all the time, and then suddenly they have like international calls, the peak, they maybe the phone company will, what's wrong with that, and then they try to contact the customer to say if this is actually you who made the call, or if somebody else, and other applications like this. So how to measure? This one is the next one is the metrics. How to the metrics of the data mining task. So usefulness. This is hard to judge. It's like user perception when we install the data mining system, right? For example, what is the benefit of that system? So user may say, it's better, but how better, they don't know, because sometimes they don't judge in terms, they don't have the real metrics. Like after we have this system, it is 1 hour faster to make decision, or 1.5 hour faster. They don't do that, but they just feel this kind of things. They just feel that it is better, or the decision is more correct, for example. One concrete measurement is return on investment. That is, whatever we get from the ratio between whatever we get and whatever we invest, which in this case is the expense of the data mining software, or the cost of developing if we want to develop ourselves, and maybe the hardware and the cost of gathering data, whatever cost, that is the investment, and then the return may be in the form of the percentage that we get, the increase in profit, percentage increase, and maybe the effectiveness in organization, for example. So this one can be a concrete index. In the book, it said that one company has like 400% up in profit, for example, after doing the data mining. So it's like this is an example that they like. Maybe may not be in the book, but in somewhere. But I mean, the data mining actually has the real potential. I mean, it can make some real impact in the real world. So, and also another thing is efficiency of algorithms. But this is not quite important. This is another issue that is different from database. That database, when we look at the database issue, they're concerned about the time, because there are so many. For transactional database, there are so many users use the same thing at the same time. So they have like concurrency and all the issue about that, and then parallel. This one, data mining, also has a parallel issue, because the data is also large, but the efficiency in terms of time is not quite a big issue, because executives can wait. It's not. There is one group of executives in one company to make the decision, for example, maybe few groups in lower levels, and so they don't have much in terms of like they can wait. It doesn't have to be in seconds. The response, it can be in minutes or in hours. If the model is quite right after 1 hour, it's okay. But it cannot be too late. Like this is not about data mining, but there's one thing that about parallel computing, and the problem, the big, so large problem about the weather forecast. You know that the weather forecast has to do. It is a big problem that has to deal with the partial differential equation, and then it has all the grid, basically all the Earth or the specific region that you want to predict or the forecast. You have to sample the grid, which contain maybe 100 variables. So of this problem, you can see that you have to run on parallel computer. It's the same thing. That this kind of thing, it doesn't have to be. But the difference is that it doesn't have to be fast like in the second, because we can wait. But tomorrow forecast has to be before tomorrow, otherwise it's useless. If you forecast tomorrow on the next week, it's just, I don't know what is that for. So this is quite the same. If it has to be sufficiently fast, but it's not a major issue. So, but the space may be, because the problem itself is the input itself is large already. So if the algorithm it came to be super accurate, can find this pattern 100%, but it takes like maybe million terabyte, and you cannot afford that. So and maybe 5 days, and so that is not our issue. And when we evaluate the real data mining, it should be reflect the real world data, the data that we want to use, not like we make up one set of data that we test. It works well with this data set, that it classifies correctly all the time, and then when we feed on the real world data, and the accuracy fall to 1%. So when testing the data, it has to be whatever that we want to test. The last one, the issues about the data mining. Most of them I already talked before, but I'll do that again because I already made a slide. in the book it doesn't